Swayam Prabha. Digital India. Educated India.
Welcome to the course Environmental Impact Assessments. In this session, we will cover part 2 of methods involved methods involved for climate change assessments in the larger ambit of methods which we are covering in EIA. In the previous part, we had covered definitions and concepts, and we also looked at the legislative framework, and we looked at certain guidelines and standards available for the domain. Today, we will cover methods for scoping and baseline studies and impact prediction and evaluation. So, accordingly, our coverage will include, we'll look into scoping for climate change mitigation, we'll look into baseline study for climate change mitigation, as well as we'll look at scoping for climate change adaptation, as well as we'll look into baseline studies for climate change adaptation. So, you may recollect that we differentiated between the term mitigation and adaptation in our previous class. So, how for these things we do separately, we look at how do we look at scoping and how do we undertake baseline studies. We'll also look at different methods for impact prediction and evaluation. Within that, we'll look at impact for project for climate change mitigation. We'll look at climate change impacts on project and on receptors. We'll also look at the interaction between climate change mitigation and adaptation. So, you may connect with the previous session about the different terms of what we talked about. Accordingly, the expected learning outcomes include that after completion of the session, you should be able to list out different methods which are available to you in scoping and baseline studies in relation to mitigation, adaptation, as well as you should be able to review impact prediction and evaluation methods. You should be able to look into a different approach which are adopted for mitigation as well as for adaptation purpose. And at the same time, you should be able to look at the impact on the project as well as on the receptors based on these concepts. For this section, we are following chapter 5 of the book Methods of Environmental and Social Impact Assessment by Ricky Tharwell and Graham Wood. So, moving forward, looking at the scoping and baseline studies, most of the available legislation and guidance we see that require climate change to be considered in the early stage of EIA. So, we see that it is very useful to consider EIA at the scoping stage right at the beginning, so that the key elements of climate change can be identified, and it can be also identified through the key engaging with the key stakeholders, and you can also check with the key legislations like what all needs to be studied here. So, examples of climate change policy framework. So, with what would be your reference would include like intended nationally determined contribution as per the Paris Agreement. So, what as a nation the nation has committed towards this agreement to meet the target. So, you need to look at those things. And so, those will be the binding provision for the country, and within that the other EIA process would follow. Scoping in and scoping out will mostly depend on nation to nation based on their legislative provisions which they have. Mostly it is suggested that climate change should be put in scope for all major infrastructure projects. So minor would not really have that kind of impact, but it's important to consider the major infrastructure projects as they are likely to contribute toward the greenhouse gases. So minor infrastructure projects, however, with no significant climate change concern, can be kept out from the climate change assessment process. So we see that according to IIA list, there are 4 key questions when you are doing this scoping stage. Reviewing under the scoping stage, you need to ask 4 key questions which you should consider to review the need for climate change assessments. So number 1, you would ask, will the proposal directly or indirectly increase or decrease greenhouse gas emissions? And if it will, to what extent? So this you should review, check your content, the case within this question. Second, you should ask, will the proposal be beneficial or will adversely affect, and will be vulnerable to climate change, either directly or indirectly. So whatever you are proposing, will it be beneficial or it will be negative, and will that particular proposal also be vulnerable to the climate change? And it can be vulnerable, or the impacts can be directly or indirectly influencing your project, and to what extent the influence is. Likewise, you would be asking question like, will the climate change affect other aspects of the environment that are potentially affected by the impacts of the proposal, and to what extent? And then you would look at the objectives of the proposal, whether impact assessment for identifying the alternatives and what measures you would be adopting to mitigate and to adapt for the climate change purpose. So you need to have those objectives in place. Further, we see that in scoping phase, it's very important to consider many of the existing guidelines. So you should look at existing guidelines. In this stage, general and broader consideration should be taken, such as you need to look at the greenhouse gas emissions. So you would be looking at those figures, but it's important for you to also look at the carbon sinks. So you'll have a complete picture of the scenario. So at the beginning, at the scoping stage, you should look at both the emissions as well as the sink. In the table, you can see the checklist as per the guidelines issued by Canadian Environmental Assessment Act of the potential questions that would help you during the scoping stage. So we see another set of questions which can help you to identify all these areas for further detailed study. So questions such as, is the project likely to generate significant volume of greenhouse gases? Emissions would happen during any phase of the project. So the phase could be exploration phase, construction phase, operation phase, or decommissioning of the phase of the project. So you need to review all those things, whether there will be what level of emissions would happen. It can be both. The emissions could be both short-term as well as long-term type. And the example of this type of the project include coal-fired generating plant, hydrocarbon production, large-scale industrial manufacturings like petroleum refining, cement, and so on. So you see those things here. You can look at the table here. You should also look into whether the project's construction or its lifetime operation will negatively impact the areas which act as carbon sink for the greenhouse gas emissions. So you have to be cautious about, are you disturbing the sinks as well? For example, like you might be causing deforestation, and then you might be also interfering with the peatland or the wetlands. So the related project activities could be deforestation, flooding of the land, or large scale changes in the land use. So these kind of activities can also happen. So you need to review all those things. Further, for the purpose of baseline study for climate change mitigation, So, in many contexts, it is easy to undertake baseline studies. So, baseline study is very intensive with data. In many of the contexts, it's simpler to undertake baseline study. Particularly, we see UK, for example, they maintain greenhouse gas inventory that contains all the UK's official reported greenhouse gases. So, one can straight away take the data from there as a baseline study, and these data are maintained by the local authority. You may see here the snip of the inventory from the UK government website. You may note how they maintain sector-wise inventory here. So, you may have a look at this. So, how much details you would provide in the baseline study would also vary from project to project. So, you might be providing the levels of emissions and what, like from what source, how it's coming, how much it's coming. So, that particular detail will depend upon project to project, like what is really the concern and how much data is available to you. So, you can also provide historical data, you can provide current data as well as the future projected data. So, in that you can provide the conditions, what's the current conditions, and you can also look at the trends in your baseline assessment while you are doing this and how you're presenting your data. So, it is important for you to determine how the baseline environment will change. Detailed quantification of greenhouse gases emissions may not necessary and will depend on the project in hand. So, it's not necessary that you take all the, undertake all the quantification of the emissions. In the example here, you can see one of the case from US. You can see the I have taken up this EIA statement from California report. So, here you can see they have given very detailed air quality and greenhouse gas emissions and how it is impacting the environment. They are looking at the air quality. In the table here you can see the ambient air quality standards and the measured criteria pollutant concentrations which have been given here. So, this link also I have provided access to this has been also provided to you. So, every country has committed for reduction in greenhouse gas emissions. There is a considerable difference in the commitment and actuals. So, we see that every country has committed for it, but how much is the commitment and how much actually they are able to do it on ground, there is a huge difference between that. So, you may note the global targets which we talked in our previous class as well, is to hold the global average temperature to well below 2 degree centigrade above pre-industrial level. So, that is the target, and how we really align our EIA process and project to project would depend on that. So, you should refer to the national determined contribution for the reference while undertaking baseline studies. So, you may have observed commitment of our Prime Minister at the 26th Conference of Parties COP26, where PM gave 5-fold strategy termed as SwayamPrabha to achieve the emission goals, which include use of non-fossil energy capacity. Then you also see that to meet 50% of its energy requirement from the renewable energy sources, as well as to reduce the total projected carbon emissions by 1 billion tons from now onwards till 2030. And by 2030, India will reduce the carbon intensity of its economy by less than 45%. So, that is what we are committing. By the year 2070, India will achieve the target of net zero. So, that you would look like such kind of commitment to really evaluate our position. Now, looking at the scoping for climate change adaptation. So, we looked at the mitigation part. Now, we are going to look at the climate change adaptation. So, authors suggest that climate change adaptation is yet very much being neglected in the environmental assessment process. So, this is not very well established, and the probable explanation for this neglect is that there is lack of equal international emphasis on adaptation. So, there is a lot of emphasis on the mitigation part, but relatively there is less emphasis on adaptation part. So, also we see that impact of climate change of the development are experienced. So, the impact are more realized at the local level, and therefore, it depends a lot on the local government to handle it. And since it's very local, there's a lot of variation about how each region experiences it. So there's a lot of variation how the impact is happening and how those impacts can be addressed. So that's why there's lack of emphasis on the adaptation part. Plus, it is said to be there's a lot of uncertainty in the projection for the future. So now looking at the project's lifetime and the climate change. So once we look at this adaptation, we also look at the project lifetime and when we look at the climate change. So what project lifetime we should really consider while assessing this. So you may know that most major infrastructure projects are likely to have a lifetime of around 60 to 100 years. So most of the major projects have this lifetime, and some of the major infrastructure projects could have even bigger lifetime, like lifetime from the operational to the decommissioning phase. So the example could be the nuclear power station could be 160 plus years. So the lifespan, the project lifespan would vary. So for the purpose of climate change, you need to take a larger lifespan period for your estimations. It is suggested that full lifetime may be considered during the study. In the figure, you can see the typical lifetime of infrastructure alongside climate change timescales project based on the projects in UK. So you can see here what's the range of time lifetime it has and how what kind of climate change impact it would have. You should consider the impacts on projects and or adaptation capacity of receiving environments. You should consider the impacts on project and or adaptation capacity of the receiving environment. So we have been seeing in all our domain that one needs to also look into this aspect, that what is the sensitivity of the receiving environment. So you need to look at in such cases also you need to look at the adaptation of the receiving environment and also look at the impact on the project by the climate changes, and you should look at all the stages of the project for the purpose of assessment. So all the stages, you're now familiar with all the stages here. So as per the suggestion from IEMA, the scoping of adaptation should involve, you should come to an agreement with key stakeholders on the most appropriate climate change projection. So to adopt the assessment and any necessary methodological consideration to be taken. So it has to be a participatory approach, and you need to look at the key stakeholders, and you should come to an agreement like what all projections you would consider here. Further, you should identify the scale and scope of the project's initial design and its potential impact. So what's really been put in the initial design and what kind of impact it might have on the receiving environment. And you need to consider that how it is going to affect, how it will be affected by the changing climate. Further, you should engage with the key stakeholders to identify the policy and regulatory regime, like within what policy framework you are working. So that understanding has to be developed here. So these are the suggestions made while you are doing scoping for the adaptation purpose. Further, you should consider certain issues for adaptation, such as you should look into the applicable regulatory and legislative requirements of nation, state and the project. So you should look at these things. Further, you should review the nature of the project, what kind of project you are dealing with, its location and resilience to the climate change. As you saw that the project lifespan also varies, the activities also varies, and the kind of impact it might have or the risk it might have also varies. So you need to look at the nature of the project. You should look at the duration of the project. What was the duration of the project? You should review the climate related parameters likely to influence the project. So we'll be also looking at the climate related parameters here. You should anticipate changes to those climatic parameters over the life of the project. So you've already seen what lifespan we take for the project. You should review how sensitive the environment potentially affected by the project is to those climatic parameters. So when you stimulate those climatic parameters, you should see how sensitive your project is to those parameters, so that it gives you an idea in cases of accidents or different extreme events how your project would behave. So you have to review the possible changes in the time span of 50 or 100 years into the future. Now looking at the baseline study for climate change adaptation. So now moving on, we see how you undertake baseline study for understanding, assessing climate change adaptation. So within the climate change adaptation, under the provision of UNFCCC, climate change models have been downscaled. So we see that the scientific community has downscaled the model from the global to the regional to the national areas, through which range of climate change scenarios can be generated by manipulating key parameters, and it can be done for the time periods to 2080s. So those things are available. It has been done for developing, so they have categorized and done for the developing and the least developed countries. So for you at the scoping stage, it is suggested to come to an agreement with the stakeholders to which scenario you would like to align your assessment with. So which time period, what kind of parameters, or what kind of scenarios. For modeling scenario, you may take minimum emissions. So as per the project, depending upon the project, you can take minimum emission scenario, or for the bigger project, you can take high emission scenarios. So as per the nature of the project. So you may also find adaptation measures. So these is like you can look at different scenarios and see what kind of impact adaptability is suitable. So you also have guidelines which gives you adaptation measures for climate change risk assessment, and there's also you can also refer to UK climate change projections. So that also gives you information on projection aspect. Further, we see for the purpose of baseline studies for climate change adaptation, you would be required to identify certain conditions. For example, you need to look at the historical past climatic conditions, you might have to look at the current conditions, then the future climatic conditions with like 15 to 30 years time period, longer time period for 50 years to 100 years or beyond the lifetime of the project. And then your future climatic conditions can be identified through available climate change projections. So you also have climate change projection, so you can also refer to that. However, it is also important to identify the possibility of extreme weather events. So you need to look at the extreme weather events like extreme rainfall, prolonged period of drought, flood, and so on. So you need to look at those scenarios also. You would be required to also study the climatic factors that affect adaptation. For example, extremes in short-term weather events, such as you can have heat wave, extreme flooding, freezing conditions, and so on. And then you also need to look into extremes in longer-term climatic variability, including precipitation over one or more seasons. So when there's heavy rain, not only one season but more than one season, and then there's regular increase in temperature. So all those things you need to take care of. Further, we see changes in average climate norms resulting in sea level rise. So increases in freezing and thawing average ambient temperature, and all those have to be taken care of. So for certain specific long-lasting projects like road project, pipeline project, it is advisable to use scenarios. So when you are using scenarios, the time period suggested is 30 years or 50 years or 70 years time, and you can also try for 100 years timeline. So when you are doing projecting the climatic scenario, you can try these timelines, and especially for the long-lasting projects, you should do this. So as you have to also review the vulnerability and sensitivity of the receptor. So in this process, you would be required to review vulnerability and sensitivity of the receptors, the community or the physical features which are on the receiving side. So, you need to look at how vulnerable that is, how sensitive that is to the existing or prevailing climatic conditions, and based on that you can classify your assessment into highly vulnerable, moderate vulnerable and low vulnerable. So, high vulnerability would indicate the receptors directly dependent on prevailing climatic factors. So, they are dependent on that, and any kind of variations on that would be then it would be considered limited variability. Then you look at the moderate vulnerability when receptors depend on some climatic factors. So, they are not completely dependent on that, but they will be able to tolerate a range of conditions, changes in the conditions, what happens. Then you look at low vulnerability when climatic factors have little influence on the receptors. So, maybe it is like they could adapt to the changes, what happens here. So, you can also develop a matrix for this purpose to indicate the sensitive receptors and the physical location of the project dimension. So, you can have topography, hydrology, soil condition, habitats and communities. You can show how the baseline for these dimensions will change due to climate change. So, you can show that. So, matrix method can also be used to indicate these things. You should also consider the possibility of reaching a tipping point. So, tipping point is somewhere from where you cannot come back. So, it is very important that you also review the tipping point, a critical turning point or a bottom line. So, that consideration should also be given. In order to review that, you would require expert judgment. So, expert judgment system would be required to make such decisions or to identify those tipping points. So, this would this was about scoping and baseline studies for climate change assessment. So, we saw all these things here. So, now moving forward, we will look at the methods for impact prediction and evaluation. So, now we will look at that aspect here. So, let us first look at impact of the project for climate change mitigation. You may reflect as per our commitment to COP26 also that project impacts on climate will depend on the degree to which the project generates energy by using fossil fuel, then what is the consumption of energy, and how much renewable energy the project is using, and how much the project removes carbon and how much it protects the carbon sink. So, all this in totality, not only looking at the emissions, but also looking at the carbon sinks and then all the energy consumption. So, all those have to be taken care of here. You may use carbon calculator such as the one which we had discussed, developed by the Scottish government for the purpose. So, one can use that also, carbon calculator. For the purpose of evaluation, we see that climate change is a cumulative effect. So, climate change, the complexity involved, because we had discussed this before. So, it is a cumulative effect. So, for that purpose, individual projects cause there is limited impact of individual projects. However, they together make a huge difference. So, one needs to look at the cumulative effect, and for that purpose one can remove the smaller projects, but can take larger project into consideration, and there are set guidelines for those where one could refer to the emission guidelines. So, Scotland provides guidelines for the purpose of estimating greenhouse gases for various nature of the projects. So, that one can refer to those guidelines as well to see that, and in our context we refer to the air quality guidelines as provided by CPCB. Moving forward, now looking at the climate change impact on the project and on the receptors. So, now we are looking what kind of impact it will have on project as well as on the receptors. Climate change will influence our environment and will be risky for the proposed development itself. So, it is just not the receptor, but it can be risky for the proposed development also. So, and the risk may be more for the vulnerable people and the communities. So, you need to identify them. So, the risk must be much greater for the vulnerable community people. So, those need to be identified. Therefore, you should review the sensitivity of the receptors under various stages of the project. Also, review the impact of the project. There might be interaction between the project and the climate change and also the other socio-economic factors. So, you may also consider that. So, as we had talked about adaptation, mitigation and also interaction between that, plus whenever we are considering the vulnerable community, then you also need to look at the actual climate change and then the socio-economic factors which might be influencing or increasing the vulnerability of the people. So, there are many sectorial assessment available for the purpose. You may find that UK climate change risk assessment, there's based which provides guidelines on agriculture and forestry, it provides on business, it provides on health and well-being, buildings and infrastructure and natural environment. So, all these sectorial assessments are available for reference. In the table here, you can see the assessment for buildings and infrastructure and health. You can see here on the left hand side, you can see the risk involved in built environment, and on the right hand side, you can see the opportunities. For example, you can see energy infrastructure at significant risk of flooding as a potential risk and reduced demand for energy for cooling as opportunities. So, you can see here how what kind of risk and what kind of opportunities are there with all the kind of projects here. So, likewise you may review of transportation project and water projects. So, what kind of risks are there and what kind of opportunities are there. Likewise, you can see the risk for the building projects. So, there can be damage to the property due to flooding and the coastal erosion. Then you can have overheating in the buildings including homes, schools and hospitals and so on. Likewise, you can see the risk on health and well-being and the opportunities. You can see that how there can be increased summer temperature may lead to increased risk of mortality and morbidity. So, there can be more deaths because of this. People can be, many more people might get sick and unhealthy. So, that's the risk. And then but the opportunities increased winter temperature may lead to decreased level of mortality and morbidity due to cold. So, less people might die because of the cold weather. So, there's both a component to that. So, for the purpose of vulnerability assessment, so how do we really take the vulnerability assessment? You should review critical interdependency. So, you need to see how interdependency is there between one factor to the another. So, the socio-economic and then all the climate change aspects. So, how they are interdependent. So, you need to identify those critical interdependency. And you may note that one failure, if you identify those interdependencies, you may note that one failure might lead to several other failures. So, for example, flooded power station lead to power cuts, and when there is power cuts, there might be lack of communication and many other services might get stopped. So, you have to really look at the interdependency between things. You would be looking at the impact now, when you review the impact, you might be, while looking at that, you might be looking at the magnitude of the impact. So, how big is the impact on the baseline conditions, under the current conditions, and what's the significance of the effect. Further, you would also see that the effect of climate change on the receptors without the project. So, you would be looking at what kind of effect the climate change has on the receptors without the project, and then you would look at the impact of project, whether it is positive or negative on the baseline scenario. So, what will happen with the project, what kind of changes will happen, and you need to define these changes if they are significant. So, that would be your, while you undertake that, that would be your responsibility to clearly state that. You should also consider the susceptibility or resilience of the receptor to the climate change. So, you may identify high value receptors. So, that High value receptors are those which have very little resilience to the changes in the climatic conditions. So, if something is not able to change to whatever change would happen, not able to adapt to that, or is not resilient to that, so then you need to identify those, and those priority areas have to be clearly stated. You need to review the uncertainty of the combined effects. So, if there is a combined effect, you need to bring them up as well. You may see the examples here for reference. Further, you need to review the interaction between climate change and mitigation and adaptation. So, this is the third component where you need to look at the interaction between them. You need to consider possible trade-offs. So, you need to see from between the mitigation and adaptation how things can be exchanged and how do they really interact with each other. You can look at the CEC guidelines. You can also see simple mileage charts. So, these charts can also be used to capture these things to ensure that we have been able to address the climate change and it's clearly covered or not. So, that you can see. So, you can make such kind of charts here. Likewise, you can also have interaction, indicate interaction of mitigation and adaptation measures. The example which we can see here is which shows the measure for biodiversity, and you can see the positive to negative impact and also win-win situations. So, how these things are interacting from negative to positive, and how one can, with the trade-offs and other things, can look at the win-win situation. So, you can look at this graph here. So, that is what we covered today. So, summarizing, we'll see that we looked at what approach we adopt for scoping and baseline studies. Within that, we looked at what we do within mitigation purpose while undertaking scoping, what we do for baseline study, as well as we saw what we do within adaptation while undertaking scoping process, and likewise within the baseline study. We further saw within the impact prediction and evaluation, how do we really look at the climate change mitigation aspect, how do we really undertake project like climate change impact on project and on receptors. Further, how do we really evaluate interaction between climate change, mitigation and adaptation, and we saw some very simple tool to represent those things. So, that's all for today. These were the references used. So, these are certain suggested watch and read for you to identify more and more of the areas and similar studies here. Please feel free to ask questions. Let us know about any concerns you have. Do share your opinions, experiences and suggestions. Looking forward to interacting and co-learning with you while exploring the subject of EIA. Thank you.